Hey, this is stream number 18. Is that what we're up to now? So, I got the 3D printed mounting plates working. I'm really liking how I ended up with that. Took me 4 revisions. So here's like 3 other prints plus an extra one. And so this board is complete. I think what I want to do now is take the lessons learned from this board and up the scale to the level of like a 36 key, 18 and 18 split. So I think the first step to do that is to go back to the schematic and lay out all the switches and all the pixels, update it, and then update the PCB and start laying things out. So first though, here's the 3D print of the mounting plate that I did last stream. So, hey there, Sarian. So it's got really dinky, it's hard to show on the camera, really dinky standoffs that kind of got crooked. And the board is really thick, it's very rigid. So it turns out that my printer, in almost every dimension, prints thicker than the design. So these holes ended up being too narrow for the switches, and the board was too thick to fit within the 2 parts of the switch. It's really hard to see it, but there's like, that's not even going to show up. This plate has to fit between 2 sets of ridges on the switches, right? So I backed it off in the second print here. So the holes are a little bit bigger. How do I show that? It's kind of hard to compare these, isn't it? Slightly bigger, but the board is thinner. It's probably hard to even see that, right? Yeah, anyway. And I fixed the standoff dimensions so that they're a little bit thicker. Hold on a second. Forgot to turn off the preview. So the holes still weren't like wide enough to fit the switches, but the standoffs were a good size. So then I went to the next rev and I made the board even thinner. Can we see that difference? Really hard to see. Even thinner, but I got to the point where it was starting to get flexible. But I did get the holes to be the right dimensions. So in the final rev, which I switched to transparent plastic, and this is actually a Rev 3.5 where I switched this Rev 3 but with the transparent plastic. The final one though is Rev 4, and that's where I did a little bit of custom cutout where the switches are. So there's less plastic around the switches, but then like thicker outside around the switches. And that got the perfect balance. 3D printer sounds such a useful thing to have. It is if you want to like print your own parts for things. So I intend to also print like a case that, like a tray for each of these that sit, not this one, but the 36 one. The trays that the keyboards will sit in with standoffs. I actually made a prototype for the standoff. So that's a standoff with a little screw insert and a little mechanical screw in there, and it works. So the screw would go in on the top, down through the board and into this standoff with the insert. And that took like 3 revisions because, again, trying to get the hole that the screw goes into to be the right dimensions, I had to make it bigger than I needed it to be because the printer is very sloppy, right? So if you form like a hole of 3 millimeters, it ends up being 1.5. So you have to make it 5 millimeters so that it actually prints at 3. So anyway, after numerous prints, 3 or 4 revs for the mounting plate and 3 more just for prototype that standoff, I learned all the lessons. So these mounting plates are really nice. Let's see, can I show that in the camera? How close can I get without it losing focus? So that's a pretty good picture. So there's standoffs on the sides there, and the switches basically kind of sit in their little grooves going around the rims of these interior holes. So it actually looks really nice. Scaling issue in the configuration? No, it's just the sloppiness of my printer. My printer's a couple of years old, so when it lays out a line of plastic, it ends up being like thicker in every dimension than the design. Also on the calibration for the up and down dimension, if I don't get it perfectly right, if it's too high, it'll drop the line of plastic down and have trouble sticking and not be precise. And if it's too low, it ends up smashing against you're squishing against the plate and getting whiter. Almost done with your project code-wise. Hey there, JP Post. That's cool. So anyway, I'm really like the mounting plates, so now I'm moving on today, trying to scale up the design to the final product. So I pretty much at this point decided that I want to make 36 keys, split keyboard, so 18 on each side, 5 rows, 3 columns, and then 3 thumb buttons. Hey there, Metro, how are you doing? Oh, I've also decided that I'm going to do away with this audio jack. We don't need that anymore. And how come the delete key didn't work there? Delete, please. The USB-C receptacle works just great. We're not even using all of the conductors. We're only using D plus D minus, and we're putting a UART over that and power and ground. I don't need the audio jacks at all. Okay. I think I want to move stuff around here because I need to make room. Let's move this over to here for now. Let's put these two together. Let's move the right-hand side stuff down here. And let me move the NeoPixel stuff out of the way. So, sort of focusing on this part of the board. Because of the delay in switching columns, I think I'm going to have columns be horizontal. So 1, 2, 3 columns, and the rows will be left to right. So there'll be 6 of them. So there'll be 5 across, and then the 3 thumb buttons I'm going to make into a column as well. Or a row, I mean. You have a question with a problem you've been having code-wise. Okay, what is it? Do you feel like using USB connectors may not be the best idea due to the confusion aspect? I'm not going to get confused. I'm making a keyboard for myself. I'll remember that this goes to the host, and these two go to each other because they're pointing at each other. The advantage is that I can do this and not worry about shorting the board. Look at that. I just disconnected one half and the other half's still working. And then I can plug it back in, and I don't have to worry about any potential short circuit. Whereas with the TRS connector, the power and ground are going to slide by each other, which would be a problem. Just thought of my idea right when you asked. Sorry. Okay, well, if you have any questions, let me know. So if I want to have 3 columns and a bunch of rows, yeah, I think this will work because I'll end up just making a bunch more switches down. So if I copy and paste and put them down here, right? And edit this and call this one column 2. Thinking some other sort of connector, JST or something like that, but it's my keyboard. Yeah, we all have to customize it our own way, right? I really, except for the soldering, which is really scary, I really like the USB-C connector because it's such low profile and tiny. Okay, so we have 3 columns, which are the vertical direction for me. So 1, 2, 3. If I was going to extend this out, we're going to have 4 more rows, right? So let's copy all of this. Three more, right? Trying to make it line up just like the others. I hope I'm doing this right. I think I am, but we'll see. 1, 2, 3, 4, 5, 6, 7. I have one too many. I only need 6. Right? Yeah, I need 6. Okay, so row 0, 1, 2, 3. Oops. 4 and 5. All right. Hey there, Stripe Monkey. What was out language-wise in 1980? Was assembly out yet? C was out there. Yeah, exactly like what Stripe Monkey said. So was Fortran and COBOL, I think, right? Pascal. Wasn't Modulo? Wasn't there a language called like Modulo or something like that? There were a lot of languages back in 1980. But I would say C and Fortran are maybe the most popular ones out then, right? Okay, so I guess I will just thinking if I want to get my switch numbers assigned correctly. I should assign them myself, right? What was the machine language thing people would use with the paper? Machine language. Assembly is just human readable mnemonics for the binary. Yeah, COBOL and Fortran were like 50s or something. Well, they were still around in the 80s. Maybe not as popular. Dad had to learn machine code, you think? Yeah, I mean, the punch cards were just entering, yeah, it's machine language or assembly. Assembly language is just a, like, yeah, a mnemonic for machine language. Like assigning names for instructions and stuff like that. Oh, I should be connecting my lines, right? I guess I have to be mousing over and then click. Wire through to there. Wire through to there. Wire through to there. Oops. I can delete that wire. Can I delete this guy? Okay. Okay, we'll do this one up. Over, excuse me. Over again. Wire to there. There we go. Oh, I need to get a wire down to here. And this down to here. Hold on a sec. This is why I always stay hydrated. Yeah, I think I want to assign my switch numbers myself. Let me get these ones out of the way. So if we're going like 1 to 36, then this will be like 37, right? $38, 39, 40. I'm just getting the numbers out of the way right now. And the diodes are gonna, gosh, I'm gonna have a lot of diodes, aren't I? Diode 40, diode 41, and diode 42. All right. So columns 0, 1, and 2, rows 1, 0, 1, 2, 3, 4, and 5. Okay. 1, 2, so this would be like 4 instead of, I gotta be careful about this. This is 3. This is 6. 7, 8, There's probably a way to do this automatically, but this way I kind of get to number them in a way that helps me remember, like, the order. "18 switches on each side." And same thing with the diodes, right? This is diode 3. This is actually diode 4 now. 5, 6, 7, 8, 9, 10, 11, 12, 13, 13. It's important to me that diode numbers match the switch numbers. Diode 16, 17, and 18. Love your tessellated patterns. Soldering that is going to be so bad. The switches and the diodes are really easy. They're just tedious. The difficult ones are going to be the neopixels. These things are going to be a pain. Soldering 36 little surface mount parts, that's going to be... I might not even populate the neopixels, to be quite honest. I'm going to put them into the PCB because then I don't have to pay to print more of them with and without. But I can choose just not to populate them and not have LEDs, right? Okay, so maybe what I'll do is I'll just delete these and copy paste. Then I don't have to repeat all that work, so delete all these and then copy these switches and paste the new ones. Oh, I need some room. I need to make room. Okay. How about I put the controllers together in the corner? Might have to split it between 2 pages, actually. Yeah, let's move. Whoops. I missed a bus. That's probably enough room? I need to move these guys out of the way. Oh no, I'm gonna run out of space. I might have to figure out how to make another page to the schematic. How about if I put one over here, the other one down here? Just for now, just so I can lay out the switches. Copy, paste. There we go. Alright. Actually, let's see what happens if I do auto assign. Which button was that? This one. Annotate. 1922. Oh, actually, I did it correctly. There we go. I just need to fix these buses. These are all right-hand buses. Row 3, row 4, right, and row 5, right. Okay. Keyboard for what? What do you mean keyboard for what? I'm making my own keyboard. It's my project. Just doing hardware and I/O connections today? Probably. Just gonna do the schematic and the PCB. Yeah. I probably don't... I don't really have very much more software to do until I have the real keyboard. And the only software I have left really are things like mod, tap, layer, switching, and making it easy to reprogram the keys. Not that it's going to be easy, but just today I just felt like that I was behind in the hardware side of things and I need to catch up. I need to get the PCB done so that I can send that out to the board house, and that has a turnaround time of about a week, during which I'll probably do software. What service do you need for manufacturing PCBs? Oh, which one did I use JLC PCB, but there are like dozen of them that you can pick from out there, right? JLC PCB did a pretty good job with this guy. All right. Okay, I need to add the columns to this symbol. I'm gonna need more room. Room is at a premium right now, isn't it? Can I like squeeze a little bit more space out here by moving these? I hate doing this. Okay, let's just delete the wires and redraw them. I'm not gonna have enough room. Actually, if I do it this way, I'll have enough room. Click, click, click. Yes, I want to make sure I don't accidentally like put things on the wrong wire. So to right from left matches. Okay. And then let's grab this guy. Put him down here. Just enough space. Just enough room. All right. Because I wanted to give more space to the controllers, because I'm going to need to update these symbols right now. So let's save this. Go to here. I need to update the symbol. What chip you got in there? I have the it's the KB2040, which uses the RP2040, which is the Raspberry Pi Pico. The controller used on the Raspberry Pi Pico. KB2040 is Adafruit's drop-in replacement for, what is it, the Elite C, or the whatever the Elite C's alternative is. I can't remember the name now. What's the hardware design process? You're watching it. So I use a KiCad, K-I-C-A-D, and the process is first get your symbols and footprints, well, symbols at least, then put them on the schematic, then lay them out on the PCB, get the traces going, and make sure all the constraints are met, and then send it off to the board house. Sometimes issues with coding languages. So do I. Doesn't everybody? Okay, so the symbol I need to edit, because I'm doing this with a lazy approach where I'm not actually, where is it, project? I'm not actually putting all the pins there until I actually need them. I need a couple more GPIOs, right? So I have all the GPIOs for the columns, the rows, but not the columns. I think I'm just going to stick with something easy to remember, which is that here's the pinout for the KB2040, right? And I'm using GPIOs 10, 19, and 20 for the rows, which are on the right side. All the ones on the left side, I'm just going to make those my columns. So I need to add, if I already have 8 and 9, I need to add 7, 6, 5, and 4, right? 7, 6, 5, and 4 to that. So we're going to end up making this bigger, because I'm going to add 4 more, right? So we can just take these and move them up. He can move over here. Actually, to balance this out, shouldn't these go on the top too? They should go there, right? I feel like they should go there. In fact, I'm like a perfectionist sometimes, but hey, that's fine, right? Let's add an what are we adding here? GPIO 7, and it is an output. We're configuring the columns to be outputs. Pin 11. There. Okay, do that about 3 more times, right? GPIO 6, pin 10, output goes there 2 more times. 5 on pin 9. I'll have to double check the pin numbers. Okay, and then GPIO 4 on pin 8. Okay, let's double check with the Adafruit guys. So GPIO 4 is on pin 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And GPIO 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. Pins 8, 9, 10, 11, 12, 13. So what's 6 and 7 then? 6. So GPIO is 2 and 3 and then ground. Yeah. All right. So let's put these guys over here. And then we can shrink this down, right? Don't have to use all the space, and then just make that like that. This can go up there. Let's put it on the right side. There, I like that. I'm being rated by user 335. Hey there, user 335. How is your game going? I'm working on my own keyboard. This is an intermediate prototype where I made all of my mistakes. Now I'm ready to make the real thing, which is going to be 36 keys. So instead of 2 rows, it's going to go out like, it's going to be 5 by 3 and then 3 thumb buttons on each side. But essentially, just imagine these keyboards just with more keys. The connectors are going to be in the same place. The controllers are going to be in the same place. I'm actually going to remove this other connector here because I don't need it. And split keyboard. That's what we're making. Oh, you had to dash? Okay. Hope you had a great stream. Don't irritate the streamer or the monitors. Might be the best phrase rule you've seen on Twitch. I mean, that's the... If I were to boil down like the average rule of all streams that I've seen, it comes down to that, right? I mean, irritate is a more politically correct word, but don't tick off the streamer or their moderators. Anyway, we're making a keyboard. This was my intermediate prototype. I'm working on the final product now. I had to update the symbol for my schematic, which I just did. And if I did that right, back on the schematic, I can tell it to update symbol from library, update. And now we got these extra pins, right? So what did it... Oh, it moved... Oh, okay. So it... Because I moved stuff up, my other signals got moved around. Let's move this out of the way for a sec. Okay, the plus 5 volts is raw. I need to delete that wire. And let's just connect it directly. Is that what I did before? Yes. Oh, actually, I had a little tiny wire between it. Okay, so I'll just do the same thing. Little wire goes from there to there. Okay, ground, we can just move that, right? To there. The not connect is on the 3.3. UART connections are on TX and RX. Oh, okay, so we need to move this down a little bit. Okay, and then the UART to the right side and the UART from the right side. Get rid of that. I just connected it directly. I didn't even bother with a wire. There we go. Okay. And then I have to connect the grounds together rather than connecting to GPIO 5, right? So delete these 2. And we're going to draw up to the ground wire there. Cool. So now I have the opportunity to renumber these. I think I'd like to count from the bottom. I don't know why I counted the columns from the top and not the bottom last time. It doesn't really matter. It's all arbitrary, right? We'll just put column 0 there, put column 1 there, put this will be column 2, column 3, and column 4, and column 5. I need 6 columns total. Okay. Let's put the U1 right there and the name of the controller there. It looks, it might get a little confusing because it looks like, yeah. What if I put that there and I put that there? That works, right? Or maybe this should go in here? I don't know. I don't really know. I don't know what I'm doing. Did I bother with updating? I should probably update this one too. Update symbol from library. Done. And then do the same thing here, right? That goes there, that goes there. This moves up to there. This break the wire because it moves up to there. This goes up here, move, just delete that wire to there. Just move this wire up to there. Delete, just delete that wire and this wire to there and wire to there. Cool. Move these off. Break the wires. Move that on there, this on there, copy, paste, column 2 and 3 and 4 and 5. Got your row column mixed up on the GPIO pins? That's okay. New board? Yeah, so this is the intermediate board. My final product that I'm trying to get to is a 36 key keyboard, 18 on each side. So this, I only put 6 keys on just to work out the bugs. So just imagine this extending 3 more sets of 3 and then 3 at the bottom here for thumb keys. But I'm turning it around because of... Oh, you're right. And I see what you're saying, Sarian. I meant these to be rows and the other ones to be columns, didn't I? Yeah, well, I can... Actually, this is better because when we look at the keyboard, these we think of these as columns, but I really want to read them on the... Okay, how did I design this? What if I just change the names around and I want to drive the rows and read the columns? I can call them whatever I want, right? So I could call this row 0 left. We can swap these, right? There's nothing that says I can't do that. And this is our row 2. Actually, there is one thing I need to change. If I do that, then I need to mark some of my GPOs as different. Yeah, let's go fix that. Symbol editor, right? Project. This one. Yeah, I need these to be inputs and these to be outputs. So input. I mean, GPIOs could be either, but I'm going to use these as inputs. I'm probably abusing the fact that how I'm using the GPIOs is being put into the symbol. It's probably not the right way to do it, but I'm just being, I'm just kind of cutting a corner here. So I do intend to drive the rows now and read in the columns. Okay, and so update symbol from library. Update symbol. Nothing should change outwardly. Okay, and then I need to make these all columns. Row 0, 1, 2, column. I mean, it makes sense now, like, orientation-wise anyway, right? Color white, mode dark. I don't know how to make the... I don't know. If anyone knows how to make KiCad dark mode, then I would gladly try it out. But I don't know how to do that. So it's going to be light mode for a while. Hold on, let me go back into the back to chat. New board, yes. You have 6 rows, 3 columns. So I just what's the word? I'm changing the meaning of rows and columns. So now we're still driving these, but I'm calling them rows. And we're reading these. They used to be rows, now they're just columns. And now it makes more sense orientation-wise. Yeah, well, now hopefully my naming won't be as confusing. Just to read something you learned in the tutorial today about pointers. Pointers are for when you want to pass things by reference due to multiple values, bytes being passed, talking about C. Well, more generally, pointers are what you use when you don't want to copy, right? So if you think about values moving through your program by loading and storing them between memory and your registers, copying is just loading and storing. If you have a large amount of data, it can be inefficient to copy them from one area of memory to another, or to copy them all into registers. You might not have enough registers. So instead, you just mark where it is in memory, that's the address, and then the pointer just holds that address. It's just a value which holds the address of where your values actually are. And they're used for numerous things, but the most common thing is to avoid copying. Can you just program them to what you want in software? Yes, exactly. You actually have to label them? No. I'm just labeling them to be consistent. Entire array can't be passed in a register unless it's very small. So yeah, exactly. Yeah, okay, so yeah. So this will really confuse people if they were looking at my schematic before. Now I'm like, whoa, I've flipped the meaning of columns and rows so that they actually now it makes more sense orientation-wise on the paper. These really are rows and these really are columns. It's just that I changed the meanings. Now rows are inputs and columns rows are outputs and columns are input. The NeoPixel is also an output, so it makes sense. My inputs are on the left and my outputs are on the right, except for the UART. Okay, so let's change this around. This is row 0 right, row 1 right, row 2 right, column 0 right, column 1 right, column 2 right, column 3 right, column 4 right, and column 5 right. Okay. Yeah, so the way the switch matrix works, if you didn't see my other streams, is that we have diodes pointing towards what we're going to ground. So we're grounding each row one at a time. And then we're reading the columns. And the columns are weakly pulled high. So if none of the switches are pressed, we'll read high or a 1 for each column, right? But let's say you press switch 1 down. Then when we ground row 0, we'll see, because of the connection here, we'll see column 0 go low. But the other columns won't. The diodes prevent like a feedback, like row 0, column 1 feeding back into row 1. Actually, how would that work? If we didn't have this diode here and we grounded switch 1, I think what it would be is we would go, how does this work? I can't remember, but like these diodes prevent the current from going the wrong way, and then making it look like we have pressed switches we haven't pressed. So yeah. So the order is we would drive row 0 low, read columns 0 through 5 to see which switches are being pressed, and then make it disable that, and then, or actually I think we're driving it back high or something, and then going to row 1, driving it low. So every row that we drive low, we sense which switches are pressed by if the matching column for this switch is also low. And we're doing that many thousands of times per second. These are numbered correctly, right? We have 36 switches, 36 diodes. Oh, this no connect should go there. All right. So the controllers are updated. Switches are updated. Let's try to compact this to give me the most room I can. Maybe I can fit it all in one sheet. Okay, and then since I have the space now, I can move this guy to kind of match. Let's put him right here. Put him down here. Okay. I have some room on the right-hand side of the sheet if I need it. Oh, let's put the USB receptacles there. So that goes up there now, and then this fits over here, and let me fix these again. So I don't need these wires anymore. Ah. I want to draw, I want to select the wire and delete it. There. Because I want to put that there, and I want to put that there. Alright. Good enough, right? Well, if I want to be a perfectionist, then I would take this and move it down slightly. There. Okay, now I think I might have plenty of space for our neopixels. I need to make 36 of them. What if I just copy this whole group of 6 and paste it? And then just connect these directly. So that's 12. I just need 4 more, right? No. 6 more? Yeah. Okay, let's connect wires. Can I fit 6 more on the page? 4, 5, 6. I think I can. Hey, look at that. Easy peasy. So, removing that no connect. So we're going to actually connect these. There we go. And then we need a wire to there and a wire to there. Ah! Okay, let's delete these old NeoPixel wires. I'll keep those around because those are the net names that I want for the right hand side. So I want to copy all of these, paste them on. Oh, I have just enough room. Look at that. Actually, let's move it up. Give myself even more room. Okay. There we go. Right? Just like that. Let's move this off to the side to give me room for my right-hand side power. Actually, I can just turn this guy, right? Yeah, why not? Because he won't fit. That's why not. Well, shoot. I mean, I guess I can draw a janky wire that goes between here. I'm only doing this because I'm running out of space. So let's just do it. Drawing janky wire. There. Okay. And that, and here's the ground. Just be consistent. Wire to there. All right, and let's do these. Annotate. Okay. Okay, I don't like how it annotated that. So let's just do it manually. So this is NP7, NP8, NP9, NP10. $12, 13, 14, 15, 16, 17, and 18. Actually, I might want to add a few more because I want to have underglow LEDs, right? You have to be careful with scoping when you return. Okay, yeah. What's the program I'm using? I'm using KiCad. Do I have a link to that? Yes, I do. I use KiCad for all the hardware designs. Are they different LEDs? Could you program LEDs? Oh, these are smart LEDs. These are NeoPixels. This SK6812 Mini E, you could look it up. There are 3 LEDs, and as implied by the drawing, they're inside of a single package. There's a red, a green, and a blue one, right? And then this is tiny little controller that understands the one-wire protocol that comes in. It's documented in the data sheet, and I didn't even have to worry about it because there's a Rust crate that handles it for me. Basically, it toggles up and down to transmit what color this should drive, and then depending on the color, RGB values, it flashes these on and off at the correct intervals to make it look like they're either on part of the way, on all the way, or off, right? Somewhere between off and on, using like a pulse width modulation. So anyway, I just say what value, just like a pixel on the screen, right? And it will illuminate the LED or not with the correct color. And they're daisy chained. So as you're writing the information in, every time you write another cycle, the LED forwards to its output what it had before. So if you wanted to fill in all 18 pixels, LED combinations, you write 18 different RGB values, and then it gets all the way down the chain. They're really neat. Fixed time delay between each. Yeah, the data sheets are kind of weird, and like I said, I don't have to worry about it because it just works for me. All I need to understand is that each one is kind of just like holding 3 bytes, a red byte, a green byte, and a blue byte. I need to write 18 sets of those 3 to in order. I think we found out that in our Rust code we say what colors we want for NP1 first and then NP18 last, and it probably flips it around, like puts it on a stack and then shifts them out, first in first out, or first in last out, so that the first one electrically that goes out goes into NP18, and then the last goes into NP1. Yeah, daisy chains and holds its previous state. That's how LED light strips usually work, is that they're just daisy chained, and you write out through a single serial port the entire sequence, and it gets shifted all the way through your chain. Okay, I need to number. Well, I need to decide, am I going to have more than 18 pixels on the thing? So that's 1 per key, right? But do I want more? Do I want like underglow LEDs maybe? I'm kind of thinking I do, and I think I want 4. The question is it going to fit on my schematic, or am I going to have to be creative about this? No, it's not going to fit. What I could do is make the chain go around. Let's see, let's just delete this for a second. Oh, I don't want to delete the nets though. Keep these nets around. Let's move this down to here, this down to here, and this down to here. Okay, what if I if I'm gonna have 22 of them, what if I take it at 11 and then move this around down to here? So let's clip the wires. I can move this slightly to the left, right? Well, I need to move it even more to the left. So shift it a little to the right. Give me more space here. Okay, because I want to make a wire from here down to there. And I want to make a wire here down to there. I suppose what I'll do is I'll just make another net. Or can I just pass a wire through here? I can. There. All right. And then let's make 4 more LEDs. 4, please. There we go. And then delete that no connect. Move that on top. Okay, then wire to there and wire to there. All right. So we're going to have like 4 underglow LEDs. I think 4 is probably good enough. I don't know how many my corn keyboard has. I don't remember. Maybe it had 4. Okay. One thing is these are all... I need to move all of these, right? It's just like annoying me that it didn't... it overwrote. It didn't fix that automatically. Don't mind me, and just have OCD sometimes. Let's get them all aligned. So does it not light up at the same time? They appear to light up at the same time because they're written out so fast. I think it's like in terms of microseconds, and it's done. We're using these NeoPixels using like a neat LED strip. Yep. So every key will have an LED under it that glows up. And they're just daisy chained together because then I only need 1 pin from a microcontroller for all the LEDs. Using a diffuser with the NeoPixel strip, the key is the diffuser, really. The switch and the key will diffuse the light, so it'll illuminate pretty much all of the key. I can show you what it looks like. I actually mounted them backwards. It's not going to focus well, is it? Okay, it's probably better to show you on the PCB. Design PCB, that is. And there I have it mounted to show correctly anyway. So view, 3D viewer. All right, so they're mounted on the flip side here, right? So they're surface mounted, but they glow through the board, so they're glowing up, and then the switch sits right on top of it, and there's like an open channel on that part of the switch by design, so that the light hits the switch from the bottom and like diffuses throughout the switch and the keycap, as long as you have a translucent keycap. What color patterns do you want to program? I haven't decided that yet. Probably I'll leave that up to software. Thought you're putting one on the edges of your board too. Well, I think for the underglow, we want, instead of it shining up, we want it to shine down. So I would mount them, but mount them flipped upside down and just have them sitting somewhere. Actually, I probably won't even use this part. I'll probably use a different part for those neopixels, which means I should probably figure that out now and remove the 4 that I added for now. Make that a TBD thing. Yeah, and I probably put the underglow ones like spaced out like 4 corners of the board roughly, or maybe 4 in the middle somewhere. Yeah, I think I don't want to use these reverse surface mount parts backwards because they don't mount very well the other way. I already had that problem. So let me just remove them for now. Actually, if I just undo... Oh, no. I don't want to undo. I just want to delete these 4, actually. And then put a no connect on there. So that'll be a TBD. I'll leave room for 4 more, but they're not going to be the same part. They're going to be the other neopixel that shines up instead of down. Okay, now the moment of truth. Do I have enough space, or am I going to have to move this guy? I'm going to move him now just because I don't think it's going to have enough room. Let's delete that wire. Actually, I can just do that now. Okay, and then probably these will go here somewhere. And then all of these get copied down to here. Oh, look at that. I have plenty of space. All right, and then wire to there and wire. That's not a good place to wire to. Let me move this guy up. Actually, he needs to go there anyway, right? Wire to there, wire to there. This guy needs to connect here and over here. I should probably make it look like I did the top one, so that would mean moving that to there and probably moving this guy up. There. All right. Close enough. Maybe he goes 1 to the right. And this one goes 1 down. All right, and then I'll auto assign. I'm pretty sure we're going to have... okay. I'm going to add 4, and I want to reserve the numbers for them, so I'm going to name this starting at 19, 20, 23. It's too bad I got to do this manually. Wait a minute. Why did it screwed up the numbering on them? Okay, I had to do this anyway because it numbered them weird. I guess it numbered them by going like top to bottom, left to right, or something like that. Am I numbering the correct thing? I am. And 40. Okay. Now that that's all done, we can move to the fun part, which is the PCB. Actually, let me verify. This output goes to the input of that. Powers. Okay, it looks good to me. So we're going to flip to the PCB. My key is 36, yes. Thought you needed more than 36 keys? No. Hold on a second, let me show you something. Let me turn off my camera for a sec. Alright. So I have this corn keyboard. I really like it, and it's been a big part of my inspiration. So it's kind of like what I'm trying to build is my own version of the corn. This has 36 keys, so it's 3 by 5 plus 3. So that's 18 per side. So I even put the controllers in roughly the same spots. There we go. So just like the corn, what I'm doing, you might have seen that I had 6 columns instead of 5. So there are 5 columns here, but then I'm thinking of making the thumb keys as just another column, as if they were just taken and moved over here. So 3 rows and 6 columns. 1, 2, 3, 4, 5, 6. And then each key has its LED, and there are plus 4 more underglow LEDs. Okay, anyway, we have to update from the schematic, right? So, update PCB. Here are all the switches we need to place. Now, someone told me that there's a way that we can just delete all of the trace. Oh, I need to also have it delete footprints with no symbols. This J1 and J4 don't exist anymore, right? I should renumber these things. This should just be renumbered J1. And this is J2. The USB is the only connectors now. Still click on that. Oh, that deleted my USB ports. I didn't want that. Where did it go? Did it put it down here? I can click on it to see where it went. Oh, it put it there. No, that's J1. Where's J2? Okay, put J2 on the right. Okay, put J1 there. Interesting. Okay, we need to move that. That needs to go on the right-hand side. Okay, so everything is all scrambled now. I'm wondering if I should just delete the old board and make the new board from scratch. Oh, it also deleted my through holes. Okay, let me undo. Beep beep. Redo. There we go. Yeah, let's just delete J1 and J4. Let's have this update. This is now J1, right? And this is J2. Update. Close. I think that's right because J2 is... Oh, I have them flipped. I have them backwards. No, this is left and that's right. J2 is right. Then I do have them backwards, don't I? J2. Yeah, I have these backwards. That's J1. J2's over here. Wait a minute. Oh, I have these totally backwards, don't I? This is the right. Did I have them backwards in the original board too? If the left board is U1, yeah, I think I just need to start over. Let's just delete all this. Okay. Let's place everything. So, oh wait, I didn't want to delete it. Oh, hold on. I don't want to delete everything because I really liked my through hole parts, which aren't there anymore. What happened to them? Let me undo a few times. There they are. I want to keep these breakaway tabs. Can I just copy this? Yeah, let me just put that over there, right? Delete all of this. Yeah. Then hit update. Don't click that. Update. There we go. All right, so we got a lot of stuff to place. Let's place the controllers first. And where's the USB? There it is. Move it. Actually, these should be facing each other, right? So like that. Right hand side. Move. Rotate. I need to set the grid on this too. It's too small. How about a millimeter? Is that too big? I need to snap this. How do I snap it? Move. Is this already snapped? I guess it is. It just doesn't look like it. Alright, anyway. Your core keyboard is 6? Yeah, there's the 6th column can be cut off. I don't like having that extra column for my pinky finger. So mine only has 5. So the sixth one would go here, but I really don't like the idea of the pinky finger reaching over that far. I just dropped, oh, I'm dropping frames. I'm dropping frames. I dropped 94 frames. Oh, I'm dropping more. I'm just waiting for my connection to stabilize. 100, nope, still going, still bad. Waiting for my connection to stabilize. 162 frames dropped. Yeah, so what I was saying, I don't like my pinky finger reaching over, so I picked one that doesn't have that 6th column. All right. So just kind of randomly put the switch. Okay, these are all the left-hand side switches, right? Let's grab the switches. Move up. All these switches too. Move them. Ah! It didn't... I held shift. How come it didn't work? Move all of these switches to the left. And these are the diodes that go with them, right? Move the neopixels out of the way. Okay, here are the diodes that go with the switches. Oh, there's some more up there. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm missing some diodes. They just kind of randomized. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where's diodes 13 through 16? I guess I can just follow the rat's nest, right? They're down here somewhere? Yeah, here's one. Here's one. All these diodes. Boom up here. Okay. We have all the switches here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm missing some. 13, 14, 15, 16. We're missing 6 of them. Well, there's switch 16. 18. 17. 15. Where's 16? Well, here's 14. And this is a mess. Yeah. It made quite a mess. I just kind of want to separate the different kinds of parts to begin with. Right here, let's move the diodes out of the way. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, there's one here that doesn't belong. Which one is it? Switch 13. Here it is. All right. Okay, so all of these switches go up here somewhere. Let's move the diodes out of the way. All right. I don't know. I think this is fun, even though it's sort of a mess. Really want to try something relaxing when you code, do e-work. Think once you finally graduate, you'll move to Florida or something. You'll code on the beach or something. Why Florida? There's lots of beaches everywhere. I think that's a mess. Try sorting out a bundle of over 200 components. I mean, we're getting there, right? There's a lot of components here. Okay. Once I get the switches all roughly in order, I'll kind of get an idea. Well, look, based on the schematic, right? We kind of want to place the columns near each other. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The rows... I mean, why don't I lay them out like this? Like, exactly like this. Why don't I just make 1, 2, and 3 the thumb buttons? Why don't I just start with that? Where's switch 1, 2, and 3? Here's 1. Here's 2. I'll put them roughly where I think they should go. Where's switch 3? Here it is. So kind of like that. These over to here somewhere. And then like... Let's put 4, 5, 6, 7, 8, like in that order. So let's put 4 here. Where's 5? Here's 5. And I think what I want to do is I want to put these right up against each other. Because if I remember correctly, they need to be 19.05 millimeters, right? Between. So that's 19.05. That's exactly what we want. All right. So then 4, 5, and 6 below it. Okay, and then 7, 8. So 8 goes here, 7 goes here, 9 goes there, right? 10 goes here, 12 goes there, 11 goes there. All right, let's bring these guys over. 13 goes there, 14 goes there, 15 goes there, 16, 17, and 18. Okay, and then roughly speaking, I measured this before. So my idea was I measured this on paper. like actually rested my hand on a piece of paper and marked like where like my fingers are kind of resting. And so lining it up the way it seemed natural to me is index fingers right over the middle thumb button. So if the index finger is on switch 8, that would mean that I want the switch 2 to be directly below that one. So kind of like this. Right? Roughly speaking. And then like the thumbs slightly offset from each other. Okay, so this is very, very roughly where the keys would be. So maybe I just set up the right side roughly the same way. So let's just grab all of them. Up here. The diodes are... I just have a mess of diodes. We'll have to sort that out later. Let's separate the neopixels from the diodes. Time to hydrate. You probably hear talking in the background because I have the rest of my family around me. That's why I have to use this screen behind me so you don't see them. Don't 1, 2, 3 want to be ordered 3, 2, 1 like they were in the extra column on the right, but rotate 90 degrees clockwise and lowered down. Probably. I just put them roughly where they go. You might be right that I might want might want to put 1 and might want to exchange 1 and 3, right? Well, when we the restness will probably help me figure that out, right? I mean, we have a bit of flexibility putting things where we want, so we'll see. So the next switch is 19, right? And just keeping it consistent, that would mean. Why don't I just do that? If your intuition says so, you're probably right, right? That I probably want it like this. You're probably right. So then I'll want switch 19 to be like down here matching it. So we gotta go find switch 19. Where is it? Where are you, switch 19? There's 20 and 21. Where's 19? 29. I don't see it. Am I missing a switch? Did I miscount? Did I misnumber them? Switch 19, where are you? Oh, I just didn't see it. There's switch 19. So like roughly in the right spot. Let's move these guys out of the way. All right. Extremely rough placement. Whoa. Which switch is that? I think its label got misplaced. That's switch 33. Where? Oh, it's up there. Your name got moved. Switch 33. I've been putting it right there. Okay. Switch 33's name got orphaned for a moment. So next is 22 to... Oh, this one's also missing his label. Fix that. Okay, 22. There's 23. 2, 3, and 4. There's 24. 22, where are you? There you are. Okay, so these three kind of go roughly here. Whoops. Didn't mean to drag them again. Okay, and then I want the thumb to be roughly under that. Oh, no, under the one next to it. So extremely rough again. Kind of like that. All right, so 25. 26 and 27. Move next to those three. Okay, and then 28, 29, and 30. Go next to it. Oh. That look... Whoops. Okay, that looks good. Okay, 31, where are you? Here you are. You go there, 32 moves there. 33 goes up here. 34. Hey, it looks like it's gonna fit on the... It's gonna fit, which I like. It's gonna fit on the page. Cool. And he's gonna go roughly here somewhere, like 3 copies of them, because I'm gonna basically print one plate with these breakaway tabs, which worked really well on the prototype. Okay. If I do this correctly, there should be no left to right rat's nest in the end. There should be completely separate nets. So I kind of want to get to that. So I have to sort out my diodes. So I just need to have some on the left and some on the right, right? These look all like they're all on the left side. But then I have some more down here that go to the left, right? 18, right? Diode 18. What are these other ones reaching from right to left? Oh, right, because these go, okay, diode 15 goes on the left. 13 goes on the, whoops. 13 goes on the left. But all of these go on the right, I think. Oh, 14 goes on the left. All these go on the right. If I did again, if I do this right, there should be no left to right. Okay, there is some down, oh, the neopixels. Yeah. What was it? 1 to 18 go left. Here's 18. Here's 13. All these go right. What a mess. Whoops. How did its name get shifted so far? I actually don't know where to place that. Oh, below. Okay. 34 got moved. It's nice that it holds on to like the things that are related to each other. So if I accidentally scramble it around, I can find them again later. Okay, so these neopixels are all on the right. So just put them off to the right somewhere. Okay, and these are all left side, I think. Mess of pixels. So these are all left. Okay, I have some crossover here. What's that caused by? What the heck is that? Oh, 14 got in the wrong group. There we go. So 14 goes somewhere here and here. Okay, cool. So save that because I've gotten the keys roughly where they need to go, and left is separated from right. So I got to place the diodes and the neopixels. All right. Would anyone honestly use long double in C? I rarely have seen long double used. Double and float are a lot more common. When you print the memory space of a variable in C by passing it a reference, why does it show a size of 8 bytes? It could be that the variable is byte aligned to the nearest 8 bytes and padded to the nearest 8 bytes. Or it could be that you're looking at a type double. Or is it a long on a 64-bit platform? So it sounds like it's a 64-bit machine then, if it's an int or a long int or something. All right. I think I had the diodes numbered right, so I could just take each of these diodes and move them to the switch it goes with, right? So 5 goes to 5. And I think I was just placing them like above the switch, wasn't I? Oh, there. If I rotate it right, yeah, I think that's what I was doing because these two connect. These are on the same net, right? That's what that line right there is. Okay, let's just place them. So it doesn't really matter the order in which I place them. Just pick them as I need to. Rotate that one around. Oh, I wanted to put them on the back side. Yeah, I made that mistake last time too. I need to flip the board around. View, flip board view. So we're on the back now, right? Can I just view front layers? Yeah, I need to flip the diodes around too, right? So how do I flip? It's just F. Okay, that's what I wanted to see because it should disappear and it should reappear if I pick back layers. Yeah. All right, so then move that to there. Okay, let's just do all layers. This one I placed right, so this needs to be flipped and then rotated to there. Close enough. All right, moving diodes. Here's diode 3. Move flip to switch 3. Right there. Diode 11. Move flip. Where are you, 11? Right here. Next. 15. Move flip. 15's right here. Actually, I could, one of the wires on the rat's nest kind of leads me to where I should go. Right? Move flip. Switch 6. Move flip. Move flip. Move flip. Switch 1. Move flip. 7. A little tedious, but that's okay. $16. 17. $8. If you hear shouting in the background, don't worry, it's the TV. The rest of the family's watching Stranger Things. No spoilers. So, if I do this right, eventually the rat's nest will calm down a bit, right? Because things will be like roughly near where they need to be. Yeah, see, it looks a lot better rat's nest wise, right? Okay, the NeoPixels. I guess we should place those now. So they also are populated on the back side. Oh shoot, I don't know exactly where to place them. Does it matter how precise I am? I don't think it does, actually. It just needs to be below the switch. So, where's 11? Right here. So I think it just goes here somewhere. Like right there. 10, move flip on the back side near switch 10 right here. 2. 13. 13, right up here. 15. Switch 15. Having the grid setting makes this a lot easier because I don't have to be very precise in the mouse movements. Just jump, goes right there. 12. There. 3. 14. Is it starting to come together? This side? Left side? 6, right? 8. See you, JP Post. What time is it here? It's 10 o'clock. NP9. 18. Almost done with 1/2. I laugh because it's like a lot of work, and probably this is boring. But I'll only do this once ever, right? I only need to make one keyboard ever. This will be the keyboard that I use for like ever. Or maybe I'll just refine it after. Make little tweaks, right? Two more. Switch 5. Yeah. You're missing a neopixel. And number 1. Okay. Yeah, this is what I was hoping to see. A lot of the traces are like in lines, so like it should match, like the grid should kind of match the schematic grid. Yeah, I think it's looking good. All right, let's do the other half. Okay, we've got some diodes. Diode 29. Right there. 22. Right there. Diode 26. 34. Up there. 24. 32. 30. I think I'm getting used to the wacky way the zoom in and out like brings me to where exactly I want to be. What it is whenever I hit zoom, it recenters. So yeah, it just kind of recenters automatically. Which is probably giving people a headache watching this. If so, my apologies. 31. But like I said, this will be the only time hopefully the only time I need to do all this stuff. 36. 21. 28. 19. 20. 33. You know what I probably should do is go back to what I had checked in and actually print a copy of the current design. so I can compare with the new design. NeoPixel 26. Right here. Actually, hold on. These aren't gonna match, are they? 23 should match switch 19. Maybe I just pick a different, what do you call it? A different reference for the, I know what I'll do. Either pick a different reference or I'll count from 37. For the ones that go underglow. So yeah, let me fix these numbers. 19. Because so that they match the switch, right? Otherwise I'm gonna mess it up. Might be worth rotating those diodes 180 degrees so that diode connections run right down the switches. I thought I did that. I placed like this diode here. Oh, Akko's not picking it. So that the trace just goes directly down. Or you mean the other side of the diode? The diode that's on the column side? So I had it, I'm placing it so that I always mix it up, anode, cathode. This side, the one with the bar, matches the switch. But you're saying flip it around so that the columns all line up? Oh, you mean like, rather than having to trace around here, actually move it down and then I can go down the side, maybe? Or do you mean like that, and then that can just go over there and these can go up, maybe? I see what you're saying. Or like, I mean, it's not that big a deal if I have to route around the side of the switch. That's just adding a little bit more copper, right? Does it really matter too much? I don't know. I'll think about it. This is only the second board I've ever made. With a little bit hanging over the side of the switch a bit, yeah, maybe. I see what you're saying, yeah. 30, 38. Let me place these first. Oh, wait. I'm getting ahead of myself. I need to finish the renumbering. 19, 20, 21, 22, 23, 24, 25. I also never move these labels out of the way. I just know I'm going to screw them up if I don't have the numbers matching the switches and the diodes. It just means that if the underglow LEDs use NP for NeoPixel, then they have to start from 37 and be on the left. 37, 38, 39, 40, 41, 42, 43, 44, right? That's okay. So, update PCB. Okay. It ended up, I guess, renumbering those? Okay, did I have any placed? No, okay. Move 38. I don't have a 38. Delete 38. Delete 37. 24. 24 right here. Let's move these closer. Oh, right there. All right. 21, 20, 19, 34 is like over here. 22. 40 doesn't exist, right? 35. $33. Hang over the side. Not the end of the world, but it might look a bit nicer. I actually don't even see the traces. What comes out really that I notice the most is what it looks like on the back. And right now it looks kind of nice that the diodes are lined up with the sockets, but it's just an aesthetic thing, right? As long as they're consistent, I think it'll look fine. 30. 30, okay. I don't think we have a 39. Wait. Yeah, it doesn't exist. 25. Yeah, it added, but what happened is it added 4, and then 4 doesn't exist anymore. 36 does exist. It's right here. 32. 27. Almost done. 31. So I definitely need to double check to make sure that these are mounted correctly, because no one, and myself included, no one caught that I had them mounted backwards, unless Sarian did, and then I maybe I was too busy, I didn't see him chat, and then it's my fault. What am I saying? It's all my fault. Okay, let me triple check with the schematic. So where is it? NeoPixel. Here it is. So ground is the notched pin. Ground is the notched pin. If it's on the left, that means it's shining down, not up. This is the shining bit, right? This is the non-shining bit. So it's going to shine down, which is correct because the switch is facing down too. If I were to flip it, now we're seeing it from the top, so this is shining up. That's correct. Okay. Let's view all front layers. Oh, right. So on the front, we only see that there's that cutout. And if we view the back layers, we see the other side of the cutout and then the pads. All right, good. Good. Hey, look at that. It looks nice and clean. Here's where okay. One other thing that I did is I did measure, like, my fingers. They're not all in a line, and even on the corn keyboard, you can see that some columns are higher than others. So I kind of wanted to match my hands, and I had written down some measurements that, yeah, the index finger is at the top, and that is that right? No, middle finger is at the top. So that is this row. So this column needs to go up a little bit then. Is that selecting what I wanted to select? Nope. If I select a little bit more, will that work? Yes. So I want to move that exactly for, well, what's my reference? Well, I guess relative to the keys near it, it's 4. Is that right? No, relative to the ring finger, it's 4 up. So 1, 2, 3, 4, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah. 1, 2, 3, 1, 2, 3, 4. Okay, so these two columns are positioned correctly from each other. Okay, so then that's from 1 to 2, 2 to no, sorry, that's 2 to 3, 2 to 3, and then 3 to 4. I need 14 millimeters. So that didn't move what I wanted it to. What didn't move what I wanted. Okay, there we go. So 45 plus 14 is 59. So that seems kind of extreme, but actually that is where I want it to be. Yeah, because I got a short little finger. Okay, and then from index to middle is 12. So that's these keys move 12 from here. So 84 plus 12 is 96. Okay, I can't do that because the thumb key got in the way. Let's move the thumb keys down. So yeah, to 96. Okay, and then from index to index left, it's 4. So these ones. 4 more down. 1, 2, 3, 4. Okay. All right, and then move these back up. Okay, and then the other thing is these have to tilt slightly. Can I just pick this one only? How about if I pick that plus that plus that? Ah. It's hard to pick all of them. That plus that plus that. All right, now I need to tilt it by, I don't know, let's say, I should have measured that angle more precisely. How about 10 degrees? So rotate. How do I, that rotates by 90. How do I rotate like 10 degrees? Gosh, I don't know. I want to rotate a certain number of degrees. Little finger's a fair bit shorter than the ring finger? Yeah, it is. It's quite a bit shorter. Yeah. The thing is with the corn, they don't have a whole lot. Like, I really want these keys way further down. I have a hard time actually pressing the top left key without moving my without moving my wrist. How do I rotate? I thought there was a way you could get off of the 90 degree stuff. There's probably something in the menu somewhere. Mate, do I have to edit it? Do I have to edit them? How about if I form a group? That's probably what I should do, right? Group them and then edit the group. I can only edit the members. Okay, fine. I can't rotate. There's got to be a way to do this. Swap layers, edit texts. What's polar coordinates do? Huh. So, yeah, just give me polar coordinates. Add an aligned linear dimension. I wonder what that does. I might have to look this up. Okay. KiCad rotate. Let's just look up how do you rotate something 45. This is just a step size. So PCB preference, global rotation angle. Okay, that's what I want. Preferences, general settings, options. Preferences. General settings. Editing options. Oh, step rotate commands. Let's do 10 degrees. So now if I rotate. Aha. There we go. So now it's rotated 10 degrees. Okay, and then I need to move the center, how did I write down here? From 1 to 4 millimeters up. So let's actually move it first. 1, 2, 3, 4, and then move it again. Rotate it. There. Okay, and then the same thing with the other thumb. So let's make sure that's together. Okay, so make it a group. Okay, and then that needs to be 9 millimeters down in my notes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then rotated 10 degrees. Like that. Is that right? Yeah, roughly. So there's the shape of my right hand. Are they rotated the right way? Maybe not. Do I have them? Am I looking at the right side? So my left and right are pretty much mirrored. So if we were viewing from, I don't know which side we're viewing from. Okay, now we're on the back. I think it is correct because I'm looking at the right. Yeah, it's correct. So home key positions are there, 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 and there. And then home for thumb is there. So yeah, my thumb usually rests like right below my index finger. Hold on, I am viewing on the back of the board. Are the controllers? No. This is the right-hand side, which is numbered from 17 to 36. Yeah, so this is correct. I think they are rotated the right way. So if I pull my thumb in, it rotates that way. If I put my thumb out, it rotates out. Kind of like on the corn, right? So rotate counterclockwise, and then the inner one is rotated slightly clockwise. We are looking at it, looking down on the right side. Yeah, I think this is correct. Okay, so a little bit of cleanup here. Let's move, there's no reason for it to be that far away from the controller, so let's move it there, and then I can compact the board just by moving these up, right? I can just place them like, well, at this point it doesn't really matter where I place it. How's the corn do it? The corn aligns that key right there. I'll just do the same thing. Never really considered it before. Actually, you know what would be cool is if I made the controller step down from the index finger. Just because I can make a cool shape. That looks like a more natural shape to me. Okay, and then grab the whole thing and move it down like that. Yeah. Okay, I think my left is just a mirror of my right, pretty much. Yeah. So I think I'm basically going by my right hand measurements. My left hand measurements, I think, are pretty much, I mean, you know what I can do is I can print this on paper and see if it feels right. Right, so then let's move this all together to match. Let's get this more precise. So if this switch is at Y of 48 and this one's at 49. Actually, I can't tell. That's at the middle of that switch is at 47 and this one's at 47. Okay, so these are lined up. Yeah, they're lined up. And then this moves up 4, right? Yeah. Moves up 4. 1, 2, 3, 4. And the next set moves up 12. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that is at Y of 31. Y of 31. All right. And then down 4 and then down 14. One, 2, 3, 4, and then down 14. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14. Okay, coordinates there is Y of 49, and over on the right, Y of 49. Cool. So then the thumb, here are the thumb keys. This one is lined up exactly there. Oh, hold on. These 3 might have to move down, now that I think about it. Where did I write this down? There's like a dimension for one from one to another. I didn't measure it at all. Maybe I should. Or, I mean, the corn, they pretty much put it right below. I'll just assume that we want it to be right there and not further down, and then I will print this out on paper and see if it actually matches. Okay, so the same thing, right? So this group, move it there, and it needs to go right there, and then it needs to move down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Get that right? So from 100 to 109. Yep. And then rotate it. So move and rotate. And make sure that these keep-offs don't intersect. If they intersect, the keys can collide. So we don't want that to happen. They can brush up against each other, but they can't overlap more than like a millimeter. Otherwise, the keys get too close together. All right, and then this one. Group. Move it together and align it up. All right, and then this one moves down 4, or up 4. Yeah. 1, 2, 3, 4. Did I get that right? So 196 to 100. Okay. Rotate that way. There we go. Cool. That's the Raimu keyboard. So I have enough space to center this in an aesthetically pleasing way. So where everything aligned, still grid aligned? Yes. Cool. Everything's nicely grid aligned, except for the controller. That's not grid aligned. I guess it is. It's not though. How come? Is it based on that pin? Pin 1? Oh, I see. Yeah, I see. All right. Do I want to be precise? Does it really matter? I don't know. I guess I should measure. How far away did I put these two? These aren't really lined up too well. Let's line them up. So, pick them up. Can I just, like, edit them as a group? E doesn't do anything when I have more than one selected. I mean, I guess that makes sense. I think because I picked them up as a group, now they're like now they have some kind of weird alignment. It's basing off of that diode. Can I base it off of that? I want to base it off of this switch. Oh, I see. It's the center of that switch. Okay. So like this switch is at 186 by 64 aligned. Okay. The diode is also aligned. Okay, cool. So it's this the keep off will be right in the middle. All right, so then that's 1, 2, 2.5, right? 2.5 millimeter. Yeah, okay. So then I should place this one 2.5 millimeters away. Right there, right? 2.5. 1, 2.5. Okay. And then, oh. Okay, this position is, yeah, then this, I guess it's because it's pin 1, it's lined up on pin 1, right? No, it's not. Well, what happened? Oh, I'm accidentally changing the grid. Okay, I have to be careful not to hit the N key. Okay, I think those are lined. No, they're not. Maybe they are. It's hard to see. Hold on. Use the measure tool. Yeah, it is lined up. All right. Never mind. Okay, now where do I put the connector exactly? Okay, it needs to be out to where this line is the edge of the board, I believe. No. The edge of the board is actually here, this line. That's the edge of the board. So move it off to the left. I mean, okay, we can put the edge of the board. We can just arbitrarily line up with that line. That's sort of how I have it now anyway. More or less. Okay, What was I hitting there? Fill all zones. It doesn't matter. We don't have zones. Hey there, Red Rampage Crumpet. Significantly more depth than you anticipated. Yeah, making the final keyboard. So I'm trying to make something like the Korn keyboard here. This is what I made. This is what I had someone make for me. I'm trying to make one of these myself, only I'm having the keys match my actual, like how it's comfortable for me. And I measured it on paper first. Can you see all those funny measurements I made? So I actually put my hand on a piece of paper and sort of outlining a little bit and tried to find the center of each finger. And so this is how my hands are naturally shaped. I'm wondering if I should tilt the thumbs even more. It might be 20 degrees. These actually might need to be 20 degrees. Just keeps getting cooler. Oh, thank you very much. I'm having a lot of fun. I think I can bring these closer together, right? So, breakaway tab. Actually, it depends on where I put the edge of the board. I should probably define the edge cut now, right? Let's do the edge cut. This is going to be fun. This is where I get to shape the board. Because I was thinking we can make it just a diagonal. I mean, like the Korn keyboard, I don't really like the shape of it. I'm thinking like make a straight line up to here, and then over, and then a straight line, and then down, and then a straight line all the way down, down to here, and then go. Might as well. This is dead space, so I might as well do a straight line up to here and then up. Yeah, so let's do this. So I want to be on the edge cuts layer, and I want to draw. So how do I do that? I guess we're just drawing lines. Here we go. Oh, it's right here. Yeah, we want to put it pretty close to that connector. Right, how close is it actually? Like right up against it. Okay, so let's go from there down to, I don't know, how much space do I want? How much space do I have now but on the edge of this board? Like 3 millimeter? Do I want like a good 3 millimeters around on either side? Yeah, let's give it 3. So then that would be decked down to here. Like down to there, right? And then let's say over to here-ish, and then up to here. One, two, three. 1, 2, 3. Yeah, like right there. And then up. I don't know. There-ish, and then up to here. Oh. I guess I need to go higher. A little higher. There we go. And then over to there. And down. And then down. Up. I didn't quite get that right, did I? Move that line over there. Move that over there. Okay, does that look ugly or what? It's quite the wire. So these are edge cuts. So this is where we're actually going to cut the board. Let's not show the what is it? The fab line. The fab. We don't care about those. So these are the yellow is the silk screen. The orange or the gold are plated through holes, and the white is actually a cut. So this is the edge of one board, right? And actually, you know what I can do? Can I pick this whole thing and just copy and flip it around? I think I can. Copy, paste, flip. Oh, look at that. That worked out really well. Okay, and then place. I missed one segment though, so I need to draw that. Actually, I'm going to draw it like this. Zoop. That means over here I must have an extra line. Yeah, there. Zoop. All right. I don't know. What do you guys think? Does that look ugly? Is that the ugly board? Hey, it's Rymu's keyboard, right? It's gonna look different. Okay, so really I want to make one edge cut all the way around with these breakaway tabs, right? So, oh, actually this is not positioned quite right. It's not quite right. I need to fix this. Needs to be there. Okay, so I probably have the dimensions wrong all the way around here. Yeah. Is that... I'm... you know, you'll have to forgive me. I'm a perfectionist. Okay. I guess it was going by center of something. So all the way around it's off by a slight amount. And we're fixing it. And this one's going to be off. There, I fixed it. All right, so we need to bring the breakaway tabs pretty close. I think I need to reduce the grid to 0.5 millimeter. Yeah, like right there, right? Then I need to bring the other board. Let's do grid 1 millimeter again. That's not quite right. I'll just do a fine adjustment of the breakaway tabs. That's what I'll do. Okay, so then, yeah, this guy. We need to center them within this channel. How about 1/4 millimeter? I mean, it's close. 1/10 of a millimeter. We'll get this thing like perfect. I think that's as good as I can do it. All right, and then basically I got to add a cut, right? So back to 1 millimeter and then edge cut, add a line from here to here. Basically going to join these boards only to break them after they're printed, right? So I'm going to delete these lines. Oh, how did that happen? How did that happen? Actually, let's move it further up. 1, 2, those are 1 millimeter, right? Yeah. Let's put them up to there. How close can I get to that? I can get pretty close. How about like that? Compromise. All right. Okay. Copy, paste. Set the grid to 1/10 again. Well, hold on. Just get it roughly. Hold on, I gotta actually go look at what I printed last time. Hold on a second. Okay. Oh, I see what I did. So here's what I did last time. Oh, it's green. You can't see it. Here, I'll turn off my color key. Color key, so you can see blue behind me. So yeah, so I made little channels between break-offs. Right? So let's do the same thing here. Let's precisely position these. So this one's at X of 143.4. .4. Accidentally clicking on the things next to it. How come edit isn't working? There we go. I clicked it finally. Okay, and then it needs to move up a little bit. So how about 3.5? That's pretty close. All right, I like that. And yeah, so I need to, what is that? I need to draw some more cutouts close by that. So edge cut, right? Yeah, between here and here, down to here. Like that. Ah, that's ugly. I'll have to fix it in a second. In fact, let's fix it now. What's that position? Well, that's a strange position. Why did I put it there? For 7.55, what the heck? Oh, because I'm judging by that distance. Okay. Yeah. So I think we need to go really small grid for this. Okay. All right. So we basically get a jagged edge when we break the board right here. It breaks along this seam here, but you know, that's okay. Let me make a copy of this. Can I just copy all of that? Nope, it's not letting me copy. There. Copy, paste. All right. And then right there. Right around there. Okay, that tells me this needs to be moved slightly down. Okay. So like right there, and then we'll move this one slightly up half the distance. Join and join. Oops, there's an extra line there. I'll have to check for extra lines. I might have added them by mistake. Okay, anyway, this moves slightly down. Oh, I moved the edge cut by accident. That's fine. That's why I want to do that anyway. Okay, cool. I think I did it. Let's remove the fab lines. Is there any concern having your pinhole so close to the seam? You mean which pinholes? These ones? They're a fair distance away. 5.5 millimeters. I think that's what they are now. Yeah, that's about how they are now on the existing board. Actually, I could measure it more precisely here. Yep, it's slightly less than 5.5 millimeters now on this board, which is transparent now. So, you know, these are through holes, but they're like I was showing before, they're meant to be broken on purpose. And yeah, these are about the distance away from the edge that I had before. I think it's fine. Yeah, but thank you for having me double check that. I think that's it. I think all we have to do now is have fun with the silk screen, and then I need to do the traces. Right, resolve the rat's nest and all that. Oh, before I do that, before I do all the trace work, I think I want to try to figure out how to print this onto actual paper and then see if it matches up. You know what we could also do? I could work on making actual curves here. Like remove these sharp edges. Like, there's no reason for me to have this sharp edge. I could just curve here, right? Can I curve from... Let's go back to grid 1. Can I... Maybe grid 1 is not a good idea. Let's just go to grid 0.1. Okay, can I form a... How does this curve thing work? Oh, I see. I need to click the center. This is going to make a... Yeah, I see. It's going to do one of those things. So then I really want to do, like, I don't know. But this is a circular curve. How do I make an oval curve? Aha! That's how you do an oval curve. Yeah, okay. There we go. Although, I kind of want to make it, yeah, like that. Which means that's more like that, right? In your pipe eco, the plastic surround of the header is 0.5 millimeter from the edge of the board. Yeah, I'm leaving lots of space. Although, I guess I'm getting kind of close with this switch here, right? Just to get rid of that harsh point. I don't know, how's that look? It looks better, right? There's still sort of an edge there. I could do a little bit more work with the curve, I guess. Can I add more control points? That's what I really want. I don't see a way to do that, though. Properties? Yeah, I guess I'd have to do it with two different curves. Unless it did something like this. I guess that's how you do it, right? Intersect it just right. Zoom, enhance. That looks nicer. Okay, let's fix this up. Look at that. Look at that nice curve there. So I kind of want to take that and copy it and paste it and flip it, right? And then place it on this side. Like that. And then reduce this to there. There we go. That looks nicer. It almost looks like wings now, bat wings. What about this harsh corner here? Should I curve that out? Now that I know how. So, I don't know. There's a certain element of art here, and I'm not the artist. Maybe something like that. That doesn't look too bad. So then just reduce these cuts to there and there. That looks nice. So then copy, and then over to here we paste, flip it around, and place that curve right in there. I mean, more or less, right? Maybe move that slightly out. Okay, and then the grid is playing with me here. Grid to 0.05? I can't quite get that to hit that exactly right. No. Okay. Really, I want the same curve. Flip. I'll just do the best I can here. Like that. Okay, good enough. So then this goes, meets there. And that goes and meets there. I like it. Look at that. Do I want to keep flattening these angles? I don't mind these angles. What do I want to do here, though? I kind of want to keep them. What about down here? I want some space to print some stuff on the silk screen. And here. Maybe just keep these. In fact, I might even make a curve there. Actually, what would that look like? Hold on. If I do a... do a curve like that. Actually, that doesn't look too bad. Right? Round it out, make it... I don't know. Let's see. Connect the dots, right? Okay, so then this actually meets there. And this is deleted entirely. Ooh, I like it. I like that. So then that curve is flipped and goes right there. Okay, so then that meets there, and this is deleted. Ooh, it's looking better every time I make an edit. I like it. That might be all that I do. I might need to move stuff around because I might need to increase the angle here. Before I forget, let me fix the preferences. Where are you, preferences? And then put that back to 90. Okay, save. It's not centered. Can I fix that? Or am I going to screw everything up by recentering the board? I hope this doesn't mess it up. Okay, did it mess anything up? It did. Because I really like that my switches are aligned on exact integer boundaries. Yeah, so I'm not gonna mess with it. Cool. Any obvious mistakes here? That looks good. Everything is on the back side, right? So if I do front layers only, actually let's do all layers. Anything obviously missing? All right, I turned off the fab layers because they were getting in my way. Let's go to front without the front fab. Okay, so I need to move the silk screens for the switches. So what did I do on the original board here? I put them kind of down. Yeah, I only really need this when I'm plugging switches in. So yeah, let's fix it. How did that one get upside down? Group, ungroup. That's weird. He doesn't want to go right side up. It refuses to be right side up. I don't know how to fix that. How do I flip him? No, then he's just on the back side. Is that a bug? It refuses to draw it right side up. Maybe I need to rotate it 10 degrees exactly to get it back aligned. Actually, I guess if I edit it, there should be an angle here, right? There's no angle. How come there's no angle? Orientation? It's this and I can't edit it. Okay, so I gotta go. I shouldn't have messed with that. 10, right? Okay. And then there we go. Oh, that's weird. It refuses to draw at certain angles. Okay, anyway. Basically moving all these, whoops. This ungroup, right? Grouping ungroup. Reference, move the reference inside. All right. Yeah, I guess I could put him in the corner. Why don't I put him in the corner? Why didn't I do that before? I don't know why I didn't do that before. Doesn't that make more sense? How come I can't pick it now? I am picking it. Why don't I just put the references in the corners? Yeah, I mean, just make it look nicer. Well, thank you for the follow. Placing traces with 5/1000ths of an inch precision. It's pretty small. Okay, now all... Oh, 17's wrong. Hopefully now they all look kind of nice. Oh, 18. All the silk screen markers for the switches look pretty nice. Let's do the other side. Group. Ungroup. And this is the one that won't draw correctly, right? Ungroup. So I gotta like rotate it back. That's whatever. It's weird that it won't rotate, it won't draw it rotated the correct way. Guessing it's a bug. Alright, almost done. Whew. Okay. Alright, front side silk screen looks okay. Or it's 1 by 2 inches. That's tiny. 7 14-pin ICs, 4 LEDs, 4 resistors, 4 MOSFETs, 8-pin header, and a 2-pin header. Wow. That's tiny. Can I move the J1 marker away? Yes, I can. I don't think I bothered to on the Rev 1 of the board, but I think it looks nicer if it's a little bit like that. Actually, why don't I just rotate it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Why don't I put it right there, smack in the middle? Doesn't that make more sense? Just put it right... Whoa. Doesn't that make more sense? I need grid to be 0.5 millimeter. There. Perfectionist. That's me. Move that. Let's move that right in the middle. Okay. Now let's look at the backside. Turn off the fab. Okay, so I need to clean this up a bit. Let's view flipboard. Okay, so we're looking at the back. So the diode markers, I didn't move them on this, but I did move the NeoPixels to the bottoms. Is that right? What did I do for between? Oh, the keys are closer together, that's why. So where to move this to? I can't move it there because it get cut. What if I just... Is that too weird to put it to the right of the thing? Does it really printing a K on all these? It is. Not that I really care. You also never soldered ICs that small before? So, Sarian, did you do drag soldering with lots of flux? Because that's what I intend to do for these. These are so small, close together, that I only managed to solder these together by doing drag soldering. They're less than 1 millimeter apart. So I just did drag soldering with as much flux as I could get. Come on, there we go. I mean, does this make sense to just put them there? I don't know. Gonna use solder paste with a stencil. Ah, professional. If I put them too close to the pad, I kind of risk it getting burned when I solder it in. I put it a little bit further away. Yeah. Yeah, Sarian, if you can and you would like to, it would be kind of neat to see your board. You could put it in the Discord or something, but you don't have to. Maybe it's proprietary or something, and then, you know, I understand. Oh, cool. It would be fun to look at, I think. Should I just mirror and put it on the left? I kind of feel like mirroring it and putting it on the left. I shouldn't get too comfortable with this stuff because I might try out Sarian's idea and move the diodes a little bit to the right, and that does change where some of the silkscreen alignment is, right? So, shouldn't get too comfortable with this. Oh, what happened here? Oh, that's that bug, right? It's not drawing these correctly because I need to rotate it back. It, for some reason, it won't, like, it won't draw it correctly. Rotate it. Look at that. It's like weird. Gotta be a bug. Come on, click it. There we go. You know what? There's another reason I don't want to do the layout tonight. I have to figure out what I'm going to do about the underglow LEDs. I have to find the part that I want to use. And get the symbol and footprint. Oh, you know what? Another thing I need to do. I need to design in the through holes. There's a bunch of things I need to do in this board, right? Did I catch them all? 23, 24, 5, 6, 7, 8, 9. Yep. Looks good. Nope. Missed 2. All right. Looking good. 1, 2. Oh, this one's not placed. Over here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Actually, can I do a quick check? Design rule check? Ooh. Well, I have 260 errors. Where's it? Oh, right there. Wait, what? Is it because those are rotated? Wait, what? Rectangle on edge cuts, but it's not. Hold on. Yeah, that's on the reverse side. There's an edge cut there? Oh, there's an edge cut there. What's that doing there? No, it's not an edge cut. It just sees... Okay, so it's confused by the rotation. It thinks that these two are too close together. Yeah, it's confused by the rotations. I think I can ignore those. It's a personal hobby project? Wow. Sounded professional. Okay, so I don't know what I'm going to do about the it's confused by these rotated edge cuts, thinking that the silk screen is being cut or the pads are being cut. But they're not. It's just that they're rotated. I wonder if I can just mark them as okay. Anyway, we're going to delete all markers. Oh, hold on. Run that again. What's this? Run it again. What, schematic parity? Didn't look at that. Not run. Okay. We have a lot of unconnected items, of course. That's where most of our errors are. Okay, I get it. I have everything unconnected. Okay, let me view the front. Blip. Okay. I need to put some through holes in here for screws. And they need to be at least 2 millimeters wide, so maybe make it a little bit more, like 2.5 millimeters. All right. Actually, the holes that are on this corn, how big are they? Two and 2.24. Okay, that makes sense to me. All right, so I need some through holes because I'm going to screw down the circuit board to slightly larger. I don't know what you call it, like a dish that's going to sit in, and then there's going to be a 3D print. Well, they're both 3D printed. The dish and then the plate that's going to hold the switches in place. And I need to put them like. Okay, can I just add them? View all layers. Actually, let's just view the front layer. Or no, I want to see both. But I don't need to see the courtyards. Or not the courtyards, the margin? What is it? That one, the user drawing. We don't need to see the user drawings. Okay, where to put the screws? Probably one here, right? So can I add that? Add, not a freestanding via. I need to add a through hole. How do I do that again? Place. Maybe it is via. Right here? No, that's not what I want. Don't want a via. I want a through hole. Do I need to just add a footprint? Hold on. Might have to look this up. How you just place mounting holes. Maybe it's just a footprint. Mounting hole. There we go. I think I want to go conservative. Go 2.5 millimeter. Or maybe 2.2. Let's see what the corn is using. I think that is a 2.2. Yeah, I think it's 2.2. I think that's what I should just go with, right? What's the difference between these two? What's a DIN 965? I don't know. Different specifications. Pad with vias. We can just do pad, right? Mounting hole 2.2 millimeter M2 pad. Yeah, M2 for the screw, right? Yeah, because that's what I'm using. I'm using M2 screws. Yeah, okay, so this makes sense. Right, so we want one of these. Yeah, like right between, because that's what the corn keyword has, right between, like right around here. And then, can I place another one? Just copy that, right? No net. Can I edit that? Can I just give it the ground? I forget which ground is which. Which ground are we on here? Ground 2. Wait. No, ground 1. Right, so let's ground this. Okay, and then copy that. And where do we place another one? Like, I mean, how many screws do we really need in this thing? The corn has 1, 2, 3, 4, 5 screws. I guess I can just copy their design. They have one roughly out here somewhere. I mean, does it really matter? I guess we'll put it right here. And then they kind of place them evenly, like one here, and then one here. And like one here, maybe? Not near that diode. How about like right there? Is that enough screws? Maybe a 5th one up here? Does that make sense? I'm not a mechanically inclined person, but it feels like there should be a 5th screw hole right here. Yeah, I'm gonna put one there. In fact, I might even put one down here, or is that too many? I don't know. So this one has a screw within like 1.5 key positions from any one key. I guess I already have that. I might not even need this hole. So these have to match up the two plates that I put between them, and the screw is actually going to go right through there. Okay, so I should put them on the other side, right? Roughly the same spots. Like right here. There's a diode there. And I need to edit that because that needs to be ground too. Where's the... Hold on. I need to edit the net for this. Yeah, here it is. Net name. Net ground 2. Speaking about LEDs, you want to learn neopixels and LED strips so you can code some cool color patterns to run under the gunwale of your dad's boat, Boston Whaler. I don't know Bluetooth interfaces. How'd you make a PCB for that light strip? Depends on what you're going to control the lights with. Like what I've seen are like for something like that, what sounds right would be like an Arduino trinket or something. So you wouldn't even really need a PCB. You can just use an Arduino and just wire it directly to the light strip. So when I was playing around with light strips, what I looked up was Adafruit light strips. This one. Adafruit's really good because they have like guides that go with any of these. So you pick one you like. Let's say like I don't know. Let's pick this one. This white wire LED strand, right? Click on that, and they're gonna have like a YouTube video that talks about it, and then yeah, on this learn section, they'll show you how to do stuff. So that particular strand might not have a guide that goes directly to it, but some of them do, and then they have these just general guides on how to do this kind of stuff. But yeah, you'll need like a coin battery if you're not going to plug it into a main line, and you have to have some kind of controller to turn if you want them to turn on and off. If you want them to be always on, you don't even need a controller. You just need a battery and a battery holder. Easy. Like something like that. Anyway, that's what I'd recommend. What's the second plugin that you have there? Second plugin to what? To Chrome? Dark Reader? So I have my React developer tools. I got Dark Reader, I got uBlock Origin, Redux Dev Tools, some random stuff. Side panel, yeah. I did some web dev in Chrome. I hope I hit the correct one that you were looking for. Okay, more through-hole stuff. Select, copy, paste. Okay, now we got a through-hole. Like I placed it roughly there. I'm just trying to like really crudely mirror this. Maybe down here. I don't know. Okay, and then one up between these two keys. Let's put it up here so that we keep clear of that diode. And then wait. Did I put it up there? Why did I put one there? Let's put it over here instead. Maybe I only need 4. Hold on. Yeah, what if okay, so what if I delete this one? Beep, beep. Delete, I said, and then move this one over to here. And maybe I only needed 4. I kind of feel like one should go there, though. So then... kind of up here is where it would sort of go. I don't know what I'm doing. It doesn't really need to be symmetrical, right? It's not symmetrical with the diodes anyway. So like a it doesn't really match. I don't know. Hey, do software for PCB? KiCad. How to do the software for the keyboard? It's all in Rust. So yeah, the software I got confused. The software program I'm using to do the CAD work for the PCB is KiCad, but the software for the actual board is in Rust. So I actually had that up in the background here. I haven't done any work on that today, but other streams in this series, you'll see me doing this. It's like, we call it the firmware, and it's all written in Rust. And it's a no standard, which means there's no standard library. So we're building software that runs directly on the microcontroller. So there's no operating system. We have some crates that we use, like Cortex-M, RT, and a few others, but it's not a full operating system. So our main function is not called main; it's called entry. And it's got weird markup on it. It doesn't return. We have to construct our own heap. So there's a lot of like very very low level stuff we have to do. But yeah, it is otherwise pretty straightforward. So like, we set up timers. That's how I'm blinking these LEDs, and handling the communications between boards and between the board and the keyboard and the computer is all done through this pole. So we do the key scanning, we pull the USB, and we pull the serial port, right? And the key scanning are things like scanning different, like driving each column low and then scanning the rows to figure out which keys are being pressed. And then we report it back to the host through this key report that in poll USB is sent to the human interface device class of the USB device. So there are many layers of the software, but short story is that it is a Rust crate that depends on a bunch of other Rust crates. A lot of them are written by RPRS group, because I'm using the Raspberry Pi microcontroller, the RP2040. And we also don't have to figure out USB because some other nice people have figured it out for us, and the NeoPixel as well. So if you're going to write firmware at a very low level or even on bare metal, in Rust, for example, you probably wouldn't want to do it all from scratch. You want to pick some foundational libraries other people have written and then build something on top of that. Anyway, short diversion into the software. All right, do I want a 5th hole here? I don't think I do. I like the arrangement of those 4. Can I replicate it here? Just by removing this one? Beep beep. I mean, that's probably fine. I'm not going to worry about it too much. The top plate could have independent plastic standoffs for stability. This is only just to hold it in place, right? So four corner, this will be fine. Okay. I might as well move these these holes closer to the keys to give me some more, yeah, like over here, to give me some more room on the silk screen, because I want to put people's names and stuff. So if we were going to draw on the front side silk screen, right? We're going to draw some text. So what I had written on Rev 1 was Rusty prototype keyboard. So instead we're going to write Rusty keyboard. I should probably put it over here, right? Rusty keyboard. And then I had like Bairaimu Rev. Okay, so this is Rev A. And then I just said Bairaimu, right? I'm just kind of copying what I had on the other board. You got to put your own name on your own board, right? Are you using this as a controller? Yeah, thank you, Sarian. So the RP2040 is Raspberry Pi's microcontroller. Adafruit makes this pinkish board called the KB2040. It's the Keeb 2040. So it's kind of like the Raspberry Pi Pico, but it has the same form factor as this Elite C Pro Micro, the same number of pins. All right. I think, so we say extra thanks to Sarian. Who else has been helping me a lot? I should thank Endorn, my other mods, right? Striped Monkey's been around for a while. I'll put Endorn's name, and then here, I'll put your name on my board. You don't even have to sub. Not that you even can. Okay, those are the people that are in chat a lot. So I'm gonna put your names on the board. Actually, can I edit that and add more? I can. Let's go look at my notes. See, the thing is, I'm really bad remembering who helps me. Well, I'm sure I will have time to add more names here. Let's, justification left on this guy. Move. There. I want to learn how to make a logo. I think we should put Ferris here, right? I don't know how to do that yet, though. That's something that's going to be part of my homework. Let me put that on my notes. Areas that need work. Board stuff. By the way, I don't think I'm going to be doing this extender thing. Even though it was a great idea, I don't know if I'll get to it. So learn how to import a logo, e.g. Ferris, into the PCB silkscreen. I just need to watch the YouTube videos that I've seen that talk about that. Okay. I kind of feel like this should be bigger. And just 2 by 2. Too big. How about 1.5 by 1.5? Good enough. All right, I'm nearing the end of what I want to stream today. I need to figure out how to print this. Really, I just want to see the front layers. Can I just print this page as is? I want to get rid of... How do I not show the The rat's nest. That should have done it, right? Oh, selected item. Okay, let's just show no layers. What happens if I turn off every layer? Is it nets? Aha. So just turn off all nets. Can I turn them all off? To click them individually? It's too many for me to click. Can I just... Aha. That did it. Okay. So, front layers only. And then turn off the fab layer. Okay, let's see if I can print this. Print. Ah. Can I just select what I had? Not that we have copper. Really only care about the edge cuts, the mask, silk screen, paste. I don't think adhesive matters. And courtyard. Yeah. Might as well pick exactly what I have over there. Did I? I think so. Black and white, print border, title block. Scale 1:1. Print preview, what does it look like? It looks not bad. Because what I want to do is print it on paper and then see if it matches like where my fingers are going to go. Okay. Print. Sure. It's printing. It's your first time on the stream, but you'd love to see more. You've hand wired 2 boards 3x3. Yeah, so the next level up from hand wiring boards is to make a PCB like this, and with something like the CAD software I'm using. And I think that it's super easy to write software for these things if you pick a microcontroller that has good support. And Raspberry Pi, you really can't go wrong going with Raspberry Pi. Oh, check it out. Huh. Okay, the angles need to be more. I could tell that right away. Yeah, I think I need to double the angles. Okay, the index finger keys. Yeah, I don't know if I like them. The angles need to be doubled, though. It's like I can pretend I have the keyboard now. Yeah, that definitely needs to be increased. How about how much? Yeah, let's double them. Okay. Thank you for the follow. So, view all layers. Turn off fab layers. Okay. Select all this. I have a feeling we're not seeing everything. Is it just because I have the nets off? Yeah. Okay, I need to rotate this more. Okay, I don't have the diode selected. There we go. Select everything, please. Okay. Select everything and then move, rotate. Okay, and then this one rotates the other way. That through hole's fine to intersect there, right? I don't want to select the through hole. Try again. Okay. Yeah, let me try that. This one now. It's kind of cool. I can just rotate the keys in my design. Oops. Okay, that is intersecting a little too much, so move it slightly over. Okay, let's try that one out. Print. And print again. I should actually measure this to make sure that the dimensions are correct. It's supposed to be 19 millimeters between switches. It's pretty dang close, if not exactly right. Yeah, I think it's good. Alright, hold on. Just had to reach over and move my chair to get it. Okay. The new printout. Oh, that's much better. That's... So what I'm doing is I'm moving my thumb to see if, like, the angle that my thumb is pointing to matches the key. And it's kind of hard to show that on the camera, but trust me, it's much better. Wait, but the right thumb is off. No, it's not. It's fine. Just because I have my hand moved. Okay, that looks good. Well, I think I'm gonna play. I'm gonna play more with this off screen to make sure it's right. And then I need to come back and learn how to put my. I want to put a nice Ferris logo on the corner here, I think, and then we'll do the tracing, the layout, which is really fun, and we need to figure out where to put the underglow LEDs. Actually, I can think about that now. So flipboard view, back glares only. That was weird. Oh, I guess for back layers, yeah, we don't have any markings on the back. So yeah, I could put underglow LEDs anywhere. You know what I'm thinking is just offset from these holes. So like one here, actually one here. So two here. What if I just put them like in a, well, like how about, I wish I had like taken a picture of the corn when actually I can look at it through the board. Hold on. Turn on caps lock. It's not plugged in. It would help if it was plugged in. Okay, now turn on caps lock. There we go. It's actually very bright. So there's 6 underglow LEDs in this thing, and they're super bright. Wow. Blazing. So it gives it this nifty, see, it's like a green glow around it, because it lights up the transparent plastic. So if there are 6 of them, I don't think I need 6. I think 4 would be plenty good enough. I care about lighting up the periphery, so I think I want to place them near the edges. So what if I put one here? I don't know. Definitely one down here by the thumbs, right? What if I put one here, one out here? One here under the controller, and then one over here. So roughly like to the right and down of where the holes are, really. You're not going with individual LEDs for each key? No, I already have those. That's what these NPs are. So those are per key LEDs. They shine up. The underglows shine straight down and catch the tray plastic alight. So yeah, the individual keys, I do have NeoPixels for those. Yeah, but I have homework to do. Actually, I should write this down in my notes. So board stuff is find part with symbol and footprint. Symbol, footprint, and model, right? For underglow LEDs. Yes, just so I don't forget to do that. So I need to do that. And then we'll be able to do the layout of this thing. I'll have to double check it a few times, and then I'll send it off to the board house, right? We'll have this thing built. Oh, after I have to figure out the silk screen. I need my logo on the front, right? I'll put the logo right around here. Okay, I really like what this looks like so far. I don't see anything glaringly wrong. So, yeah. I'm happy. They turn back on the nets. How bad does it look like? Doesn't look that bad, actually. View all layers except fab. What was the key to show all connected nets? Is it just X? Yeah, there we go. So yeah, these do need to go in a line. And that hole is in my way now, right? So I might want to do what Sarian says and flip these, maybe rotate them 90 degrees. So that they'd be easier to route. Yeah, okay, I'm glad I put the throw holes in there, because that might change my decision about where I put some of these diodes. Okay, so that's what, power, and this one's ground? Right, and that's... These are how they're chained together. Wow, that has to go way down to there. I might reorder the NeoPixels too, because some of these routes would be easier to go left-right than to go up-down. Like us to go all the way down to there, and then there, and then there, and then that. Where does that connect to? Way over there? Okay. So I might swap the places of some of these NeoPixels. I mean, that one's fine, right? It's just when we go from there all the way up to there, wouldn't it be better to go... Yeah, I should probably order it where it goes like to there and then back. Maybe you should just do a circuit around the board. So there and then up and then down and then up and then down and then up. Something like that. Or maybe the other way. It would go directly over to here and then down and around and down, up, down, and then across. That would make more sense, wouldn't it? People like their small keyboards. I love my small keyboard. Why am I using a 36 key? Because I don't need to move my wrists. So I only need to move my fingers at most one position over or diagonal. And the sacrifice is that you have to use 3 thumb keys to pick different layers. That has taken some getting used to, but I don't know. I really like it. It's very portable, right? Just pick this up and go. I don't know. I think it's cool. It's not for everybody, though. Okay, I think I'm just going to save this and check it in. It's funny how like compressed this is. I guess that should be on my homework as well, as learn in KiCad. Learn how to split schematic up into multiple sheets. So it's mostly just me looking this stuff up on YouTube. There's plenty of YouTube stuff out there on teach you the basics of how to do this stuff. Okay, so that's all saved, right? If I close that. So it's checked into my repo here. I think we're just checking this all in. I don't know what PRL is. Anyway, this is all going in, right? Git commit. So this is work in progress, moving up to 36 key keyboard. So what did I do? Update schematic to define all 36 keys with their LEDs. Neopixels, right? Remove TRS connectors. What else did I do? I did design, well, update PCB to place all switches with diodes and neopixels. Spatially according to my own comfortable finger positions. And then I design a nice edge cut around the split the keyboard with what's the thing called again? I can't remember. My words are hard. We'll just end it there. Right. Add screw mount holes in PCB. M2 screws. What else? That's basically it. That's all I did. Push that. All right. I don't know why that keeps happening, but I'm just going to ignore that. I think that's about it for me. It's midnight, so let's find someone else. Oh, Musin's still going? Let's raid Musin. Well, hold on. Musin's not doing what I was doing exactly. Well, we'll raid him anyway. He was nice and raided me the other day. So, I haven't done it today, but I've been doing my keyboard firmware in Rust. Musin is one of the most knowledgeable people about Rust that I know of, and he's usually either playing World of Warcraft or he's streaming himself working on random projects in Rust. So that's what he's doing now. The only difference, well, one big difference, his stream, he doesn't have microphone or camera. He just plays music in the background. It might be your thing, might not. But if you want to learn more about Rust, he's the guy to ask. And he's always working on some fun stuff. So hope you guys enjoy that. I'll be back in a couple days, all right? See ya. Thanks for watching. Bye.